Hey everybody, welcome in that new series of tutorial regarding cloth simulation within Golaem. This is the first video of the series, and in this video we'll cover the overall setup, scales, and all the prerequisites you need to make sure are set into your environment to make sure that everything will work properly. Golaem is using Nvidia Apex technology for its cloth simulation, which means that if you want to configure your cloth properties, you also need to install the physics plugin for Maya, which has been developed by Nvidia. Into this Maya session, I'm running physics plugin for Maya 3.4 and also Golaem 7.3.8. Just a quick word regarding the physics plugin. It has been discontinued by Nvidia in 2018, but the really great news is that from March 2021, we are not taking over the maintenance of the plugin, and if you go on packages.golaem.com, you can now download that plugin that we compile ourselves. It's now available for most recent versions of Maya, and even better, we're really excited to let you know that it's also working for Linux as well. So in the past, Nvidia didn't compile the plugin for Linux, so you had to find the Windows box to use that plugin. Now we're providing a Linux distribution. If you're going to use the plugin with Linux, make sure to also check the FX FAQ within our documentation, which can be found into the FAQs category. It will let you know how to install the plugin correctly for Linux. When you're using Windows, you need to only use the Maya module path environment variable. Within Linux, you also need to set the LD library path. Also, the more we use it, the more we figured some known issues that we're going to correct or that we're going to provide workaround with. So make sure to check that page regarding the current errors or different stuff you'll have to work around. I'm also going to really encourage you to download the documentation that we provide both for Windows and Linux. This is the only place where you'll be able to figure what are all the attributes doing in detail. So this is the official documentation from Nvidia. Okay, so let's get started within Maya. The first thing you really want to make sure when you're dealing with cloth simulation is that your playback speed is set up to play every frame. Similar to Golaem, cloth also relies on simulation, so it means that every single frame needs to be evaluated. So if you're using real time, Maya will optimize and probably skip some frame when the computation will be heavier. So make sure to either use the play every frame free or play every frame max real time, which will cap your frequency of display to 24, 25 FPS depending on what you provided. So this is the first thing you need to make sure. The second thing you need to make sure is what's the current unit that you are using, and this is really critical here. So here I'm using one character from the character pack from Golaem, and I scale it to 100%. Well, I apply a scale of 100, so it's 100 bigger than what you can get from the character pack. And I set the Maya linear unit, I'll let it to the default value. So first thing is make sure that your linear unit is always set up to centimeter, whatever the strategy you're having into your studio. It's pretty well known that this setting here will break Maya physics system if you change it. So it's kind of agreed that we never change this. So here, Nvidia physics will consider that the linear unit is going to be centimeter. Here I'm in a situation where my character is in centimeter units as well. So one grid square is 1 centimeter. So it means that now my character is in centimeter unit. It's probably 180 square. But if you are working into a different unit for your characters, there's no problem at all. We also cover the different scenarios here. Okay, so I'll do a really quick setup here to get started and also show you how you can bring that setup into Golaem and make sure that everything is well inlined. If something is not correctly in line, you'll have problem regarding gravity computation or scale computation. So also may want to provide some details regarding the setup of your character. Make sure that within your transforms, everything is scaled to 1:1:1. You don't have any non-uniform scale or non-1 scale. And also on your skeleton, make sure that everything is scaled to 1:1:1. It's really critical for the physics plugin to make it work properly. So here, my character, my root bone is 1:1:1, and every single bone of my hierarchy is the same. Here, my transform are also set to 1:1:1, so I'm all good. Excellent. So obviously the clothes I'd like to simulate here is going to be my flag clothes, my flag mesh. It's just a plane here, but keep in mind that if you want, you can also provide some meshes which have a volume, which has some white. Here is just a planar surface, but if you provide some volume here, you'll have to also define some specific attributes on it. In this setup, we're not going to cover every single clothes attribute. We'll do a really simple setup, and that's going to be the topic of the second video to go through the different parameters you can play with. So the first thing I'll do is select my mesh I'd like to convert as a cloth, and I can go into the physics shelf, and either I can use that button here, which allows me to create physics clothing, or I can go into the physics menu, into the physics clothing submenu, and say that I want to create a clothing. From that point, it's going to create a specific node which has the name of my mesh, postfixed with clothing node, and if I click on it, I'm getting all that clothing attribute that I can assign on my character. Also, I end up with the physics transforms at the start of my scene that I can expand, and within that physics transforms, I get a rigid solver. So the solver is kind of the nucleus. It's where all the casual shared attribute will be stored and changed. You've got attributes such as what's the ground 8, and you want to use the default ground. Where does the gravity comes from, some specific tools about debugging your scene, and one critical parameter is going to be the gravity amount. So here it's set up to 100 times the Earth gravity. So Earth gravity is 9.81. Here it's set up to 981. The direction of the gravity is minus y, sorry. So it means that all the characters, rigid body and clothes will be dragged towards the minus x direction with a gravity amount of 291. Here, this is because the physics plugin considered that we are in centimeters units. So this character is 100 times bigger than a regular character, which should be, that size here. So this is the right value here, and you really don't want to change this if your character is in centimeter units. Let's say maybe you don't have a centimeter sized character, and maybe you have a character which is a size of 1.8 grid square. So now you will be in meters, so it will be a character which is 100 times smaller than the one we're having here. It will be a character really small, somewhere like this. If you have a character which is 100 times smaller, you want to divide the gravity by 100. So it will be, instead of 981, it will be 9.81. If you're in decimeters, you'll set up your gravity to 98. If you're in other units, I'll let you make that change. So it's really critical that you, from the start, depending on the size of your character, you always set those attributes properly. Because afterwards, within Golaem, the gravity will be set automatically for you, depending on what's the crowd unit to change, what's the crowd unit you're going to use, and it will change the value of it, so the computation will be the same than within the Nvidia Physics plugin. Okay, that's great. So in terms of control, whenever you do a new close, you need to use those buttons here to rewind, play the sim. And now you're getting some warning messages saying to you that your close has not been set yet, which makes sense. Once it's played, you can stop, and you can also move a frame forward. So by default, you need to use those controls. Let's say you don't want to use always those controls, and you also want to use Maya timeline controls. We're still within the rigid solver. You can enable native time controls. So here you can rewind your sim. You'll get that same error message. play for a couple of frames and you can see the exact same results. So it really depends the way you want to work. Okay, so you may have noticed the error messages we're getting is an error message saying that we haven't defined any max distance onto our close. So this is the minimum setup we need to do on our close character, on our close mesh, to be able to use it as a close. It's to define that max distance. So let's go into the closing node. As soon as I open it, I've got plenty of attributes. We'll cover all of them into the second video. But what we can do as a minimum setup is to define a vertex behavior and paint that vertex behavior. So we're still getting that error message, so let's fix this. And we're getting that error message so many times because we're using the Maya timeline controls. If you disable this, you don't get this error message popping all the time. So as soon as I paint it, I'll get a tool settings, which really looks like the regular Maya paint tool. And actually I can use the exact same shortcut than the Maya paint tools that you can have for other features. And you can see that now you can paint something called the max distance. So there's multiple different attributes. Once again, we're not going to go through those ones here. That's kind of annoying. So let's disable this for the moment. Okay, great. So the max distance, it's something you're going to paint for each vertex. So let's go back into my mode here. Paint, okay. This is something you're going to define per vertex, and it's a distance you're going to apply onto your vertex. It's the maximum distance along the normal that you would allow that vertex to move when it's going to be simulated with your close. So if you want to constrain your vertex displacement, this is exactly where you're going to specify that value. By default, most of the time you end up with a value of 1 and your range is between 0 and 1. If you paint that value, you'll see that the vector that you're getting is super small. So this is how much you allow your vertex to go to either that direction, the normal direction, or the opposite normal direction. So when you are like me with a centimeter setup, you may want to change your visible range and multiply this by 100 or more depending on what you want to do. And the value I want to paint is actually 100 here. You can enable that visualization mode. Make sure that you always rewind your simulation to the first frame to be able to see those lines. You can scale them down also if you want to not them to take full control of your viewport. And now you can paint the value. You'll see the meshes changing color and you'll see that displacement being allowed for every single of your vertices. Notice that if you don't provide any value, it will be a value of 0. So it means that you don't allow any vertex displacement, and that can be convenient for all those vertices which will be constrained to your actual character. There are some vertices here you don't want to use close simulation to control them, and if they have a weight of 0, they will just act as a constraint. So here I'm painting every single vertex except those in the border, and I'm painting a value of 100, and I'm kind of good with this. So let's close this for a moment. And if we go back, rewind our simulation and press play, now we've got a close simulation being enabled on the character. There's some parameters we will be able to change. Once again, we'll go through those later. You can, let's say you're not really happy with the displacement of that character, you can go back into the rigid solver, and there's plenty of physics closing visualization to help you deal with some various stuff. One which can be convenient is, let me figure where it, oh, okay, you can display the max distance onto your character. So when you play your simulation, you can see now how much distance your vertices are from their initial position. So it's a good way to check if you painted enough variation on it and see what's exactly computing right now. You can also display the velocities. Maybe in some situation it can help you figure what's going on because maybe there are some collisions. So there's plenty of tools. Once again, refer to the physics documentation to know more about those different attributes. Great. So let's say you're really happy with that system here. If we want to inject this into Golem, we need to export those per vertex attributes and those closing material attributes into a specific file that Golaem can reload afterwards. So what we're going to do is select that geometry there. We're going to go into the file export selection menu, and now into your drop down, as soon as you've got a physics plugin loaded, you've got a physics extension that you can apply onto your characters. So let's export this into a convenient space. You want to also really make sure that some options here are checked and set up correctly. So you want to go into the physics clothing and say you want to export your clothing physics assets. Right now we don't have any collision rig, but later into the third video we'll see how we handled this collision rig and how we take them into account. But when you're doing a flag, that's not something that you want to really take into account. What's super important is that your send unit is 2 centimeters. We've seen this before. This is the setting we've put into Maya. And you also really want to make sure that the output unit is centimeter as well. And that's super important that those two are aligned properly. The rest of the options are not going to be used by Golaem, so you can just let them with the default values. You just specify a name, so let's go with flag. We're going to specify the unit here. So it's going to be our flag centimeters, and we're going to export our selection. So it has written onto the disk a flag centimeters file, and now we can use that APX file, which has just been exported to create a simulation. So what I'm going to do is within the same scene, I'm going to do my setup. Notice that right now, as of March 2021, there's just a conflict between the physics plugin and the Golaem plugin when you're under Linux. So this is not something you can do. You have to open 2 different sessions, but we're going to fix this soon. So probably by the time you look at this video, it has disappeared from the FAQ. So the first thing I want to do is load a character file. So I've prepared a character file, and we're going to jump into this so we can see exactly what's going on. We've got a flag character. As soon as we create our type, we end up with a manager node, which is kind of the nucleus but for the crowd. And as our scene and our character is in centimeters here, and we want to have a centimeter scene and simulation, I'll go into my manager and I'll make sure that my crowd unit is set up to centimeters. Once again, it's super critical that you set up the crowd unit correctly. If you want to use that centimeter character into a meter scene, you'll just let this to meters and you scale down your characters using the entity types. But if you're using a centimeter scene, make sure to use the right crowd units. As a notice, if you don't set up to centimeter, when you're going to create your population tool, you'll notice that it's super small and it has super small radius. So it usually means that you're not being aligned those properly. So let's remove this. If we set up our unit properly to centimeter and we create a pop tool, now we'll get something which is scaled properly. And same goes for the gravity and all the physics parameters at the same time. So I'm just going to do a quick 2x2 grid. 2x2 grid. I'll orient this into the same direction than my character in my scene, provide some distance between my characters, and press create. If I run just a couple of frames, my character is just made of the flag, so that's good enough for now. We don't really need the character geometry for this example. So if I want to inject that APX file I just created, what I need to do is go into my character file. So I'm going to open it from here. So this is my skeleton. It still have all the character bone, but in terms of geometry, it just has the flag geo. I'm going to locate my mesh, which corresponds to my clothes. And when you select the mesh, you end up with a clothes asset file, which usually is empty. And this is where you're going to say, okay, this mesh here has some clothes data. Let's load that clothes data. So this is the clothes data we just exported, flag centimeters APX. It contains all the per vertex stuff we've been painting, all the attributes, so on and so forth. And when you're happy, you save that file. So now that mesh has a APX correspondence, and it allows us to run some close behavior on it. I need to close that tab. Once again, this is some requirement from physics, because when you open your character, there's some physics context being created. So you really want to make sure that that tab is closed by the time you use this into a simulation. I'll show you later what happens if you don't do it. And so let's run the simulation. You'll see that nothing happened, even if we've been defining some APX file on it. So this is something we need to enable with some behavior. So I'm gonna open the behavior editor for my character. I'm gonna drag and drop that guy with the green cape. Make sure not to pick the orange cape. Make sure that if you want to use the Nvidia Apex close behavior, you're picking the green cape. I'm gonna drag and drop this into my system here, and the only setup I need to do is specify what's the mesh I'd like to simulate. So I'm gonna open that helper, and within that helper, every single mesh which has an APX file being attached will be presented first. So I can select that one here. And now I'm saying to my system, okay, as soon as the simulation starts, apply the APX file to those meshes and do a simulation. So if I run this, now I've got my simulation with the exact same attributes than the one we've been specifying. So we've got the attachment of the vertices here at the base, and the rest is reacting the same way. As you can see, it's going through the ground. So what we can do as an additional data is to add that geometry as a collider. So you can see within the closed behavior, we've got a rigid body system here. So I can select, make sure that you're using a volume, do not use a plane, make sure to use something which has some weights in it. And I'm gonna convert this as a crowd rigid body. I selected my mesh, press on the crowd rigid body button. Now it's creating a physics correspondence of this. Make sure that it's set up to a box, so collision computation will be faster. You may want to reduce the friction, the bounciness, and so on. So let's put the friction to 0. And let's add this to our behavior. So I'm gonna select my rigid body from my outliner. I'm gonna press Shift to keep the selection from the outliner, but also select the behavior at the same time. And I'm gonna press the map button. So now pcube1, the physics representation of it, will be used as a collider for my close. And the next time I'll run my sim, now I've got my close reacting to that attribute. So what happens if your character is still open? So let's open our character within the character maker. The next time you throw a simulation and you run a couple of frames, you end up with no close simulation here. And you may have noticed that I also had a error message into the script editor, which is saying that Apex close simulation can't run properly. Please close all the tabs in the character maker before launching the simulation. So you also see within the behavior editor that that behavior here is red, so it means that it cannot run for the exact same reason. If you select, you can see that same error message. So if you want to fix that error, you need to close that tab, make sure that it's been saved, and the next time you're going to throw the sim, you'll have the simulation happening properly. So now what I can do is go here, go into my close node, and maybe iterate on some attribute, export and overwrite that flag centimeters APX file. And every time I'm going to run the Golaem simulation, I'll have the corresponding simulation happening. So let's check if they're aligned properly. So I'm going to enable native control. So I'll have both at the same time, my physics behavior and my close behavior. And we can see they are kind of reacting the same way. They have the same band resistance and vertex deformation and so on. They are corresponding. So really the takeaway here is make sure that your gravity is set up properly. Make sure that your manager crowd unit is also set up properly, because this is where gravity multiplication will apply. And if you got anything which is not in line with each other, you'll get some issues. Also make sure that when you export your APX file, you export it as a centimeter output unit. So this is really important, and I really want to stress this into a specific video before jumping into the rest. Into the next video, we're going to jump into the understanding of all clothing material parameter, and into the third video we'll see how we can have some collision with the actual character when you do some K-bumps or close up clothes. So hope that helps, and see you into the next video.